First question I'm going to ask is, what is a program? You already know, we answered it on the first day itself. What is a program? Set of instructions. Machine level instructions, do you agree? Or high level instructions? High level instructions cannot be executed by your computer. Machine level instructions can be executed by your computer. Right? So we convert the high level instructions to low level instructions by using compiler. Fine. Now program is nothing but set of instructions. What is a process then? Yes. To run a program, to execute a program, operating system has to do a set of things, set of steps, like allocating memory, allocating some registers, creating some data structures like process control block, updating process tables, generate a unique process ID, lot of things. Operating system has to do some steps to start your program, right? All these steps to run your program is nothing but we call it as a process, right? Okay. Memory is allocated, registers allocated, process control block is created, process table is updated, but in my program there is some code. Who will execute the code? Operating system will start something which a part of process called as a thread. Operating system will start a thread. The responsibility of the thread is to execute your instructions. So tell me, thread is part of a process? Yes. Thread is a part of a process which is started by operating system. The responsibility of the thread is to execute your instructions. So if I ask you, your process is going to execute your instructions? No. Inside process, there is a sub process we call thread, which will execute your instructions, right? So thread is a sub process, that means it's a part of a process which will execute your instructions. There can be n number of threads inside a single process, right? Now I say, to create a thread, what the operating system has to do is, it has to allocate a stack, minimal thing. For every thread, a thread stack will be there. Thread stacks are stored in which area? Stack area, as we discussed. So if an operating system has to start a thread, the operating system has to create a stack, allocate memory for that. Yes, operating system will be ready to start a thread, right? But to create a process, many things have to be done, right? So we say that process is lightweight, process heavyweight, thread is light. That is the reason why we call thread as lightweight, because to create a thread it's very easy for an operating system, but to create a process it has to do a lot of things. So thread is lightweight. Okay, you understood what is a thread. Now tell me, what is multi-programming? What is multi-processing? What is multi-threading? Okay, anyone? What is multi-programming first? More than one program. Executed in the same computer, one after the other. Do you agree? Or parallel? One after the other or parallel? Parallelly. If I say one after the other, first process takes say 5 minutes. Second process will start only after 5 minutes. But computer is so fast, we execute parallel. So multiple programs executing parallelly on a single processor is multi-programming. So my Windows is a multi-programming operating system. It can run multiple processes parallelly. Then what is multi-processing? Multiple processors, right? More than one program running on multiple processors. So my system is a dual core processor, let's say. There are two processors on my system. So multiple programs running inside a multiple processors is called as multiprocessing. Right? You have learnt about distributed processing. Yeah, in networking. So can I say in distributed processing it is multiprocessing? Multiple programs are executed on multiple processors, different systems totally. But for us as the end user, I will feel that they are executed on a single system. Right? What is multi-threading then? Multiple threads running inside a single process. Right? One process can have multiple threads. So how to start a thread? That's the question, right? Can I write a program to start a thread? Can my program start a thread directly? Yes, but not directly. Who is managing everything in your computer? Operating system. So whenever your program wants to start a thread, your program has to request the operating system to start a thread. Finally, operating system is the one who is starting your threads. But through your program, what you have to do? You have to talk to the operating system and ask the operating system to start a thread. Right? Different operating systems are there. So the way to communicate with each operating system is different. Right? But Java abstracts us from the underlying operating system. So we don't worry what is the underlying operating system. But our program has to interact with the operating system, right? So in Java they gave a class called as java.lang.thread, right? In java.lang.thread class there is a method called as start, which is having a native code. What do I mean by native code? A code which is particular to a particular platform is a native code. One thing what I want to ask is, can you call a C program from your Java program? Yes. By using something called as JNI. In Java there is an API called as JNI, Java Native API. From a Java program you can call a C code. That's possible, right? So in a class called as java.lang.thread, there is a method called as start, in which they have written some native code that will ask the operating system to start a thread. So already the code is there. So what you need to do is just create an object of thread, new thread, and then call start. That's all. The thread will start. But after thread starts, what it has to do? It has to run some code. What is the primary purpose of the thread? To run some code. So what code should you run? Should it run? You have to tell what code it should run. Right? So a thread, the primary purpose of a thread is to run your code. You have to define the runnable code in a class which is implementing an interface called as runnable. So to create your own thread, the first thing what you have to do is you have to write a class implementing runnable, and inside that you have to write your runnable code. So first I'll start a simple program. You can just listen first. I'll give you time to type. Just listen and first understand the concept. Once the concept is understood, you will be able to write it very easily. I'm creating a new project. 7 threads. Okay. Now I'll create a new class. I'll say package as com.mysys.threads. Okay. Okay, and I'll give the class name as print name thread. Why I print name runnable? Why I gave this is I'm going to write a code which will print its own name. Every thread will be given a name by default. You can also assign a name. If you don't assign a name, a default name will be given. So what I want to do is I want to write a thread. I want to start a thread which will print its own name 100 times. That's all. Its own name 100 times it should print, right? So I'm writing a class which is implementing runnable interface. If a class is implementing runnable interface, we have to implement the methods present inside that also. I am implementing run. Now whatever code you write here is the one which will be executed by the thread. So I'll just say system.out.println, just I'll print in a loop for int I is equals 0, I less than 100, I plus plus. Just for now what I'll do is I'll print the value of I. I'll modify the same program to print its own name. Okay. So what I told you, to create your own thread, you have to create an object of thread and then call start. Operating system will start a thread. But once the thread starts, you need to tell what is the code it has to run. If you want to tell what is the code that should be runnable by a thread, first thing is you need to create a class which is implementing runnable, and you implement run method, right? And you want to tell that this is the method to be run by a thread. How to do it? Just see here. I will write one more class, thread starter. This will start a thread. I'll take main method. Now here, okay, I didn't take. Okay, I'll take main method, and here I'll create an object of print name runnable is equals to new print name runnable. Right? Is the thread started right now? No. If I run this program, main thread will start by default. Main thread will call main method. Here I just create an object. Then create a thread. So what I'll do is I'll try to create a new thread. New thread. See, there are a lot of constructors for threads. There is one constructor which is taking runnable as parameter. Can I pass my print name runnable object? Yes, that is implementing runnable. I can pass it. So I'll just do it. I'll take it in a variable of thread t is equals to. Now tell me, is the thread started now? Not yet. You have to call start method. So t dot start, and after that I'll do system.out.println inside main. Right?
You need to implement all methods which are implemented.
Yeah, in runnable interface there is only one method, run. So I implemented only that one.
Okay, if there are any other methods, you have to implement all methods.
You have to implement all the methods, or you have to make your class as abstract. If there is at least one abstract method, you have to make your class as. So actually in runnable there is only one method, run. So I implemented it. Right? Okay. Now I'll just give a breakpoint here. How to give a breakpoint? By double clicking. Right? I kept a breakpoint here. Now also I'll keep a breakpoint here. Now I'll show you by debugging. Just observe carefully what will happen. Right click, debug as Java application. Okay, it's asking me to switch the perspective. Yes. So now I'm in debug perspective. how many threads are you seeing right now? When the control is here, there is only one thread, main thread, right? I will keep one more breakpoint here, okay? Then I will press this button equal to F8. Now see what happened. How many threads are there? Thread main and also thread icon 0. For default name given for the thread is thread 0. Right? There are two threads. This thread is suspended at line 8 because I kept a breakpoint there also. And these are main threads. Both threads are suspended mode. Right? So if I click this one, it will show me it is suspended here. Right? What is the top of stack showing now? When the control is inside a particular method, top of the stack will be always shown for that thread. So this is the top of the stack for this thread, for thread 0. Right? If I keep my cursor on here, now you are seeing the top of the stack for main thread. So two threads are started. Right? When is the thread started? Once I call thread dot start. Once thread is started, immediately it is executing run method of the runnable operator. Run method is called at line number 8 of running system, right? So to start a thread, it is very simple. First start a class implementing runnable, then do like this, right? Now what I'll do is I have selected main, and I'll do like this. Now how many threads are you able to see here? Where is main thread? Main thread terminated. Once the control came out of main method, the main thread terminates. Once the control comes out of run method, the other thread also terminates. But in the loop I have kept a breakpoint, still it is there. Main thread terminated. So who created this thread 0? Main thread. Main thread terminated. But still my Java program is running, right? So if in a process, if at least one thread is running, the program will not terminate. If all the threads are terminated, then the program will terminate. So here still my program thread 0 is still running, so it did terminate. The main thread terminated. So understand, there is no parent and child relationship. Who was the parent of thread 0? Main thread. Main thread has created thread 0. So main thread is parent and this is child, but there is no parent and child relationship. Parent can die before child. Can terminate. Is the meaning of word die, terminate. Parent thread can terminate before child thread. There is no parent and child relationship. Right? Once the control comes out of main thread will terminate. Once the control comes out of run, this also will terminate. So what I'll do is I'll just remove a breakpoint. Double click again. This will remove the breakpoint. Now I'll press enter. So both the threads are terminated, but now we can see 0 to 99. Right? Now I have a very basic question. Tell me before I ask. The code inside run method, who is running it? The code inside run method is executed by whom? Thread 0. The same code can be executed by some other thread also. So see here, in my thread starter, what I'll do is I'll just create one more thread, T2. T2 also is taking what? Same runnable object. So same code is executed by two threads. Is that? I just debug again. Just see here. I removed a breakpoint there. Okay, I'll keep my breakpoint again here and I'll debug. So debug. So now till now how many threads? That when the code is executing this line? Now I will just press F6. Thread is not started yet. F6. No. Once I call start, thread 0 started. Then again F6, F6, thread 1 has started. So what these two threads are executing? Same code. The code inside run method. Both the threads are suspended because it has a breakpoint. So same code can be executed by multiple threads. Right? The code inside run method is executed by multiple threads. Now what I want to do is I want to print the name of the thread. I want to access the name given to the thread. The name given to this thread is thread 0. This is thread 1. I want to access the name, right? Now see the logic here. I'll just kill it, terminate it. Okay. See here, coming back. Here, this code is executed by some thread, right? I want to get the reference of a thread object, right? Here in main method, there are two thread objects, T1 and T2. But inside run method, I want to get the reference of threads who are executing it. Same code is executed by Tn, but I want to get the reference. How to get it is, there is a class called as thread dot current thread. Inside thread class, there is a static method called as current thread. If you see yes, that's a static method. I will get the reference of the thread. What is the current thread returning? Thread object. So I'll get the reference of the thread. Right? Then once I get the reference of thread, what I can do is I can say current thread dot get name will give me the name plus I am printing. Right? So this is how, by using thread dot current thread, you are getting the reference of the thread object which is executing. So now again I'll debug. Let's see what will happen. Okay. See here, same code is executed by thread 0, thread 1. Now I'll press thread 1 is executing, is it? Now I'll click here for thread 0. Are you seeing the output now? Thread 0 is getting a chance. Again thread 1 got a chance, is it? This is actually the name plus II concatenated, is it? Remove the last part. This is thread 0, this is thread 1. So both the threads are executing concurrently, right? Now thread 1 is executing still, then again thread 0 got chance, right? So all the threads are executing concurrently. Once the thread comes out of run method, that will terminate. Now I just remove the breakpoint. All are terminated. Now if you see, the output are interleaved. See, if it is 1, this is output of thread 1, this is output of thread 0 there. So I showed you how to create multiple threads. We understood how to create threads. First of all, the main duty of a thread is it has to run some code. Which code to run? You have to tell by providing an object which is implementing object of a class which is implementing runnable. So whenever you are creating a thread object, you have to pass runnable object to it, then call start. Right? Now, calling start method. What is it doing? It is interacting with the operating system. In start method, there is some native code which will interact with the operating system and request to start a thread. Operating system will start a thread. And this start method is internally calling run. After the thread is started, thread start method is calling run. Next, what I want to talk about is, what if I call a run method without calling start? Will my code inside run method execute? I don't want to call start, I'll call run directly. Will it execute? See, in third class there is a method called run. What if I call run method directly on thread? Will it execute? Will I see the output? Same output. Yep, see? It printed, but what is the name of the both the threads? So what happened? Run method was executed by whom? Main thread. In this case, only one thread was their main thread. Thread 0 and thread 1 were not created. Right? What will get executed? But only main thread is executed, not thread 0 and thread 1. Right? So if you want some code to execute concurrently, you have to start threads. So to start threads, you have to call start method. If you call start method, only separate threads are started. Otherwise, main thread only will execute it. New threads will not be created. So you saw the output, right? Okay, if I call t.run, tell me, is this thread a class? It's a class. It is creating an object. Then calling method. It is just like a method call on some object. New thread is not created. This is normal class. It's just like a method call. Who will execute this method? Main thread only will execute this method. These are all the right? If you call start will start a new thread, and that thread will execute the run method. Right? Next thing what I want to talk about is, thread is a class which is present already in java.lang.thread package. Actually, if I show you the documentation of thread class in java.lang package, thread class is implementing already. Thread class is implementing runnable. So that means there is run method inside thread class also. So to be very clear for your understanding, I am writing a class similar to thread class. I'll just say my thread. Okay. So this is just for your understanding, don't write it. So actually the thread class is implementing. This is how thread class looks like, just for your understanding. So there is a method called as run, right? And also thread class is having a variable private runnable its interface, right? And there is a constructor of thread which is checking runnable, right? And inside thread class there is a method called as start. Is it public void start? Inside this start method there is some native code which will request the operating system to start the thread. After that is executed, that means after thread is created, what is the start method doing? It is saying it's checking if runnable not equals null, then runnable dot. See here in thread class there is one more default constructor. So to create thread you can use either this constructor which is not taking anything, or right? So if you use this the constructor which is taking runnable as parameter, runnable will not be null, right? So what are we doing earlier? I am calling this constructor of thread class, it is taking runnable. So runnable is not null. Then what are we doing? We are calling start, right? Here there is a code which will ask the operating system to start a thread. After that, if runnable not equals null, is it satisfied? If I am using this constructor, yes. So it will call runnable object dot run. So that run method was called. This was the earlier scenario. Suppose if I don't use this constructor, if I use default constructor and call start method, what will happen? This will not be satisfied, right? In that case, else what? Run. Already thread is implementing run method, right? There is some implementation. Yes. This will be executed. Whatever is here. But actually in thread class, this run method is just empty. Okay? Just empty. Now, can I write a subclass of thread? Yes, thread is not final. Any class which is not final can be subclassed, can be extended. So what I can do, I can write my own class extending thread class and override run method. So this is another way of starting creating your own. So now suppose if I do it, I will do it like this. Just see, I will give you time for typing it. Just see, now understand it. New class print name thread extends thread. I will override run method. Okay, and here I could write the same thing. I want to print the name 100 times for int I is equals to 0, I less than 100, I plus plus. I want to get the name of the thread. System.out.println. How to get the name of the thread? Thread dot. Yeah. Actually, when I was having runnable as a separate class, I want the reference of current thread object. But here, print name thread is extending thread. In that only get name I can call. Get name is inherited, right? Right? Now in this case, if I write thread start, what I could do? New print name thread and then call. Similarly here also, instead of new thread and passing runnable, I can call new print name thread, then I can call, right? So this is another way to create your own thread, right? Now in this case, I am calling the constructor of my print name thread. My first line inside the constructor will be, I didn't give any constructors there, but constructor will be like this. First line will be the call to super. Super means default constructor of thread is executed. That means if this is a thread class, I just showed you for demo. Default constructor is executed. So runnable will be null. Runnable reference will be null. Then what am I doing? I'm calling start. So if I call start, will this be satisfied? No. It will call run method else run method. But this run is overridden. Always overridden method will be called. So my code will get. The output will be same. This is another way of starting a thread, creating your own thread. Just extending thread, overriding run method. Right? It is so simple. Which is better to use? Extending thread or implementing runnable? This seems to be very simple, but this is not good. Simple things are always not good. Why? Why is it not good? Tell me. Yeah, output is same. Performance also is same. But design wise, it is not good. This class is already extending thread class, right? If I want my logic to extend, my class to extend some other class, no, it is not possible, right? If I am implementing runnable, here is my logic actually. Here is my logic actually. Here my class can extend some other class. So while writing my own logic, business logic, I have a chance here to extend some other class. So design wise, implementing runnable interface is best when you are creating your own. Any doubts? Right? Okay, just do this change. Now let us understand the threads can have priorities. So in this case, once I start the thread, each thread will be interleaved with each other. The output we are seeing it as mixed, but we can set a priority to thread so that the thread which is having highest priority will always be given a chance to execute than the lowest priority thread. To set a priority, what you can do is you can just use thread object dot set priority. Priorities are numbers between 1 to 10. Priority is taking what? Set priority is taking int. 1 is a priority. 1 means having least priority. A thread which is having value 1 as least priority, 10 is the highest priority. By default, if you don't specify the priority, that thread will be having priority 5 in between, right? So to define those in thread class, there are some constants inside thread class. In thread class, see here, there are static integers, static final integers actually. Max priority is 10, min priority is 1, normal for priority is 5. By default, all the threads will be having normal priority. So what you can do is, in your program, you can give priority to your threads and set any value, 0, 1 to 10, right? So one thing which you need to understand is you need to set a priority to thread before starting one. After starting, if you set the priority also, it's of waste. So I can say for this priority is 10, and for T2 I'll say T2 dot set priority as 1, or I'll do the reverse. For T I'll say 1, and for this I'll say 10, and then I will execute. But still you cannot, you can see that thread 1 is coming last. If I execute again, it might be different. The output again might be different. Again the output cannot be predicted, but we are just hinting the thread scheduler to give priority to thread. But again, depending upon the OS, priorities may be sometimes ignored, right? Setting priorities to threads may not be good always. Why? Can you tell me a reason? Setting priorities to threads may not be good always.
You don't know how much time it takes to run that part of it.
Yeah, if suppose if you have assigned a priority to a particular thread, and if that thread is taking longer time, let's assume that there are 10 threads running parallel, right? For 3 threads you give lowest priority, for 7 threads you give highest priority, right? At any point of time, if the thread having highest priority is ready to run, that only will be given a chance. The lowest priority thread will not get a chance to execute, right? What is starvation?
The lowest priority threads will not be executed at all.
Yes, starvation. Starvation means hungry. The lower priority threads will be hungry of getting CPU, hunger of CPU. When you are giving priority to threads, highest priority threads only will get a chance to execute always. The lower priority threads will always starve for CPU. Such a condition where lower priority threads will not get a chance to execute is called as starvation in operating system terminology, right? So if you are giving priority to threads, there might be a chance of starvation. Some threads may starve for CPU, right? So some of the operating systems may ignore the priorities even though you give. It depends on the operating system again. But many of the operating systems are taking care so that starvation condition cannot be seen, can be overcome by using some technique called as aging. What is aging?
Increasing the priority of the priority of the lower priority.
Yes. So aging means operating system what you will do. Suppose if there is a lower priority thread which is not getting CPU for some timeout. Priority of the thread will be automatically incremented by 1. Still it is not getting till timeout, again by 1. After some time this will become the highest priority thread, it will get a chance to execute. So there is no chance of starvation. So all major operating systems will avoid starvation by using aging technique. So we need not worry about starvation in our program. Operating systems will take care, right? What I want to do is, in this case, will the main thread terminate before T1 and T2? Yes. But I don't want it to happen. I want the main thread to wait until T1 and T2 are done, right? So what I can do is I can write here T1 dot join. So T dot join. What is this doing? It's throwing some exception. I'll just throw it for now. What is the meaning of T dot join? Whoever is executing this line, who is executing this line, main thread, will go to suspended mode, will be waiting until this object thread for this object terminates. So main thread will come here, execute it, it will go to sleep state, it will go to sleep mode, it will be waiting until this thread is complete, right? So this line will not be executed until this that T has completed. Suppose if I want my main to wait until T2 also gets terminated, then I should say T2 dot join, right? So my main thread will wait until T and T2 complete, right? Let me just run it. Let's see what will happen. See, my main thread output came at the end. Always, how many times you run, you can see that at the end only, because my main thread is waiting at this line for the two threads to join them.
Priority of main thread is also 5.
Main thread also is 5. All threads are having equal priority, non-priority by default. Right? but there are overloaded methods for join. There is a join method which is taking long. What is it saying? Waits at most this number of milliseconds for the thread to die. So you want the main thread to wait for say 1 minute, not more than that. What you can do, you can use join and pass time in milliseconds. 1000 into 60 is 1 minute. So if the T1 is not completed by 1 minute, then we will proceed. You can specify the maximum time of wait by giving the parameter 1000 into 60. This will wait for 1 minute. Any doubts? So once you understand about join, let me talk about some issues of threads. Threads will be sharing. What is the heap? The heap memory allocated for JVM will be shared by T1 and T2. True or false? True. So the memory allocated for JVM will be shared by T1 and T2. If an object is created by thread 1, that can be shared by thread 2 also. So two threads can share objects. When sharing, problems come. What type of problems? Synchronization problems come. When two persons are sharing something, definitely there is a problem. Synchronization problem. Let's take an example, a very famous example and a very good example to understand. If two persons are sharing, like take me and my wife are sharing a same bank account. Okay. My debit card, I have ICICI bank card. For one account, can I have two cards? Yeah, it's possible. For same account, if you ask, there will be one card on my name and one card on my wife's name, but both of them will be pointing to same account, two debit cards for same account. It's possible. So what I did was I took two cards, one on my wife's name and on my name. Will there be problems now? What type of problems?
Both of them work the same time.
Yeah. So on 1st of every month, generally salary gets created. So I promise, let's say we will go for a party. On today is 1st, I'll take all you to party. In party, we made a 5,000 rupees bill. Then by the time I gave my card, there is no money in my account. What has happened? My wife has taken all the money from the card. So is there a problem? Of course, we are sharing same bank account. Yeah, there is a problem. Is there something wrong that my wife took all my money? No, she can also take my money. That's not a problem. But she should have at least intimated me. When she has taken the money, I should be given some information, right? Yes, information. I could not have taken you to the party. Now who will pay the bill? Okay, that's a different thing. If I don't have money, then you have to pay the bill. So you are giving money to me. Explain. So when there is sharing, such problems will happen. Now the problem is not that my wife has taken money, but I should get some intuition. That's the thing, right? So how to solve our problem? Tell me. Okay, we had this problem. How to solve our problem? Give me some suggestions. Any suggestions? No, for a wife and husband, for me and my wife, give me some solution. So whenever I said, okay, to my wife I said, okay, whenever you go to ATM, call me. Will that be okay? Will that solve our problem? Okay, now I'll just improve the scenario. Even though there is zero balance in my account, Can I use my debit card and pay the bill? No. I think, what is your bank? Citibank? HDFC? I think HDFC is giving a facility for you, overdraft facility. That means even though there is 0 rupees in your account, you can still use your card. Because you are employees of a good company, they will provide you this facility. Thinking that on 1st of every month again your salary will get credited, they will deduct immediately. So they will give overdraft facility, but high interest will be charged. 5% from day 1. For each day they will calculate. So you can use, but you have to pay high interest. So when I gave party to you, I paid a high interest to the bank. So we want to avoid that. That means if zero balance is there, if the balance is not there, I should not be able to withdraw. I should not pay the bill. That is the condition. Now tell me a rule. Whenever I am withdrawing some money, I have to first check the balance, then withdraw. Suppose if I want 10,000, but if there is only 5,000 in my account, if I go and withdraw 10,000 directly, the amount will come, but my balance will go negative. Then I am charged high rate of interest. So before withdrawing, the rule can be to check the balance first, then only withdraw. Will this condition satisfy? Will I end up paying interest now? So what? If my wife goes to bank, before withdrawing, she will check the balance. If the balance is there, she will withdraw. Now even if I am going to withdraw, I will check the balance and then withdraw. So there is no chance of going to negative balance, is it? Is there any chance? Yeah, both of us will go to 2 different ATMs at the same time. Both of us will check the balance. First my wife check the balance, okay, 10,000 is there. Then immediately I check the balance in another ATM, I will get 10,000 balance. Both of us will withdraw, again my account will go into negative. So that also is not a solution. The thing is, I then after facing such a problem, then I said, before going to ATM, call me. After coming out of ATM, call me. So we will not go into such problem. So in the same way, in threads, we can solve the problem of synchronization by using something called as locks. So same thing, whatever I said about wife and husband problem, I will just try to implement it in Java. Let's see how to solve the problem. First just see here, don't write, just see what I am doing. What I want to do is I want to create a class called as bank account, and I want to create a thread for wife and husband. One wife and husband thread. I will start 2 threads, one for wife and one for husband. Both of them they will just call withdraw method on the bank account. Let's see. Just if you see the program, you will be able to visualize. Creating a new class bank account. I'll give you time to do it. Just so in my bank account there can be a lot of variables. I'll just take a variable now, private int balance. Okay, account number, lot of things will be there, but right now for our interest only balance. Then I will write a method. I'll write a constructor for it. Generate constructor using fields. Okay, then I'll write a method public int withdraw. Withdraw method will take amount, how much amount to withdraw, right? Then I'm writing condition if balance greater than or equals to amount, then balance is equals to balance minus amount, then return how much? Balance or amount? I return amount, right? You asked for 10,000, you should be given 10,000. Else return how much should I return? If there is no balance, don't return. Right? That's fine. Now, for us to be giving some information, I will just write system.out.println. Before this, how to get the current thread. This code will be executed with some thread. How to get the reference of the thread? Thread dot. Current thread. I got the reference of thread object. Then I just want to print current thread dot get name plus is withdrawing plus, right? It will show. If it comes into if block, it is withdrawing. If it comes to else block, not able to withdraw, right? So I'll just write sorry for and just to make fun I just said better luck next time. Okay, let's see who will get this better luck next time. Okay, so now I wrote a bank account class where I wrote some small logic to withdraw, and it will print who is withdrawing actually and who is not able to withdraw. Okay, now I am going to create a class for thread. I will say new class husband and wife thread. A single thread class for both, because the logic of husband thread and wife thread is both to withdraw, right? Same thread class. Should I implement runnable? Implement, sorry, runnable. Okay. Then here I just write private bank account and I'll give a constructor which will take, but I want to give a name to my thread. But is this extending thread? Okay, before I talk about that, generally if I have a class implementing runnable, how to start a thread? New thread and pass this object, then call start. 2 steps. Or can I do like this? New thread, here only in the constructor new thread which is taking runnable. So what object shall I pass? This current object. This means current object. Is it implementing runnable? Yes, I can pass this. So I created a thread object and passed a runnable dot. So now just see, if I just create an object of the class, constructor is executed. Here I am creating a thread object and passing runnable object dot start. Just creating an object of this class is start a thread. This is better. If I don't do this, how do I start a thread? if this is not there explicitly, let's go here to thread starter. What I have to do? I have to create husband and wife thread. I'll say run r is equals to new husband and wife thread and pass the account. I'll show you how to pass the account. Then I have to say new thread and pass r, then dot start. Right? This is a way to start a thread explicitly. But if I do like this, what will happen? Just creating an object of husband and wife thread and passing account will start a thread, right? So generally we follow such an approach. In the constructor itself we create a thread object and then just analyze this scenario. Let me know if you have any doubts. Now here in the run method, what I will do is I'll just call account dot withdraw, and I'll just want to withdraw some 10,000 rupees. So once the thread starts, it will just try to withdraw 10,000. That's all, nothing else. Okay. Now I will write a separate class for starting wife and husband. New class synchronization demo. Okay, here I'll take main method. Okay, so here first what I'll do is I'll create an object of bank account. Bank account is equals to new bank account of 10,000. Initially my balance will be 10,000. Okay, then what I'll do is I'll say new husband and wife and pass. So I passed. Okay, then new husband and wife, then I passed. So now how many threads will start? First, when I run the program, JVM starts and main thread starts. Account object is created. Two thread objects are created. For two thread objects, reference of same account is given. So that means two threads are having same account, right? So here, once the thread starts, what is it doing? Withdraw. So two threads will try to call withdraw on same object, right? Now I just run. Let us see what will happen. Now both of them withdraw. How is it possible? Okay, again I'll run. Both. Now thread 0 has withdrawn, but thread 1 output may not be same, right? Two threads can be executed anyway. So what has happened in earlier times? Both has withdrawn, right? What has happened here is, just see here. In withdraw method, what is there? Let's assume first thread came here. First thread balance was 10,000, greater than or equal to amount. It just enters it, but after some time, the time allocated, every thread will be executed by thread scheduler. Let's take an example of round robin. Thread 0 got suspended. Then thread 1 got a chance. See, this statement was not executed by thread 0. Immediately after it came into if, it was suspended. Then again the second thread enters. For this also, that sufficient, satisfied, because balance is not directed, right? So for both of them, they came inside and executed, and both of them have the output as withdrawing. Right? Any doubt? So sometimes both of them has withdrawn. If both of them have withdrawn, my balance could have gone to negative. I want to avoid that. Right? Now what I want is to simulate withdrawing every time. I'll explicitly make the thread, after executing this line, I want the thread to go to sleep mode. Release the CPU and go to waiting. So I'll call a method called as thread dot sleep. You can make the thread to explicitly go to sleep state by calling thread dot sleep, and in milliseconds I'll make it to sleep for 1 second. Okay, so this is, I'll just catch. I'll just make it to throw exception. Okay, then coming back here, why is it giving error? Because withdraw method is throwing exception. Can I make my run method to throw exception? Here, am I not overriding run method? Overridden method, can it throw extra exceptions? No. The run method inside runnable is not throwing any exceptions. Overridden method should not throw any exceptions. So you have only chance to catch it. I will catch it. Right? Now, just to explicitly make every time to withdraw, I made thread dot. So now every time I run the demo, both of them will withdraw. How many times ever? Because I am explicitly, after checking the balance, it's going to sleep state. Other thread also will enter. For that also, that if condition is satisfied, so I am able to see both of them are withdrawing. Right? How many times you run, both of them will withdraw. Right? The next thing what I want to tell is, if I want to avoid such a scenario, I want one condition. Whenever one thread is inside this withdraw method, let's assume that 0 gets a chance to execute first, it will be inside withdraw method. You come here, you check the balance, it will be going to sleep. So still it is there inside. Another thread should not be allowed to enter into withdraw method. So if I want such a thing, what I will do is, I will make this method as synchronized. So what will happen if I make this method as synchronized? So whenever a thread is entering inside a synchronized method, it will take a lock on the current object. On which object am I executing withdraw method? On account object. Account dot withdraw I am calling. So I am calling this method on a object. Whenever any thread is entering inside synchronized method, it should take a lock on that object and then enter. Let's assume wife thread has taken a lock, entered. It is that this wife thread is sleeping here, right? That means CPU is released by wife thread. Husband thread tries to enter, but before a thread enters any synchronized method, the rule is what? To take a lock. But already wife has taken lock and sleeping here. So husband will not be able to get a lock. So husband thread will wait until the lock is released. After some time, wife will get a chance, will execute this, come out of the synchronized method. Whenever a thread comes out of the synchronized method, the lock will be released. Right? After that, husband was waiting for lock, he will get a lock, enter inside it. But now by this time balance will be 0, this condition will not be satisfied, then we can, right? So we have totally solved a problem. We will never go into negative balance, right? So by using synchronized method, we are solving that problem. Just I will run, see, always thread 0 is executing. Right? Okay, I just want to give a name instead of thread 0, thread 1. I just want to give a name. How to give a name? Just see here. If I use this constructor, previously I was using thread which is taking runnable. There is one more constructor in thread class which is taking runnable comma name of the thread. If I use this constructor, yes, I will be able to assign a name. So coming here back to my thread class, I am calling super of what? Default super, is it? Sorry, this is a thread constructor, is it? I am calling thread constructor which is taking runnable. So I can pass name here. So what I will do is I will take here comma string name and pass, right? And while creating object, it requires second parameter, the name of the thread. Let's say wife. Right? So this names will be passed to here, and I am using the thread constructor which is taking runnable comma name. So the name is given to thread, like whatever I like. Now I will just run it. Let's see who will withdraw. Always wife will withdraw, no problem. Oh, husband is withdrawing. Right? Wife is withdrawing. Again wife. Earlier we saw husband as also withdrawn. Wife is always a pair. Any doubt in this code? I will explain it again, then I will give you time. Okay? Threads are inside a single process. All the threads inside a process will be sharing the heap memory. So it is possible that two threads may share same object. In this case, if you see, main thread is creating a bank account object and passing the reference of same object to both the thread objects, for wife thread and husband. So in this case, wife thread and husband thread are both sharing the same account object, right? So when I create an object of thread here, in this case the constructor is executed. Here I am starting a thread, right? So once the thread is started, it is just calling withdraw method. That's all. Both the threads are trying to withdraw 10,000. But before that, what is the balance? 10,000 only. Balance is the 10,000. Both of them are withdrawing 1,000, 10,000, 10,000. Now, in this bank account, if this method was not synchronized, what will happen? Let's assume for the first thing, wife enters, it will check the balance, print it, prints wife is withdrawing, and then it will go to sleep. When the wife thread is sleeping, husband thread will get a chance, it will also enter. Again, balance was not deducted, so this condition is satisfied. Then again, it also prints husband is withdrawing. So both of them will be able to withdraw in this case. To avoid such problems, what I want is, whenever a thread is inside a particular method, I don't want another thread to enter inside it. So to make that condition, what I did is I made my method as synchronized method. So in Java, if a method is synchronized, only one thread can be inside that synchronized method. So in this case, let's assume wife entered first, the project is executed. When the wife is entering the synchronized method, it will take a lock on current object. You will be calling withdraw method on an object, the lock will be taken on that object, and wife thread enters. It will go to sleep. When it goes to sleep, the lock is not yet released. Wife is taking lock and sleeping inside. But when the thread is still inside. If another thread tries to enter, it will also try to take a lock on that object, but it is already locked. So the other thread will wait until the lock is. So after some time, the thread will wake up, it will execute and come out of the method. When the thread comes out of the method, synchronous method, the lock will be automatically released. Then husband thread will get a chance to execute, but by the time this condition is not satisfied, so both of them will not be able to recover. Right? Any doubts? In operating system, if you have still remembered, what is mutual exclusion? In operating systems, I think you might have done it in first year or second year. What is mutual exclusion concept? Either only one processing. Mutual exclusion can be applied to process as well as threads. Only one thread can be inside a particular block, right? So in this case, is mutual exclusion satisfied? If I am using synchronous methods, only one thread will be inside this method, right? And even in operating system, if you have understood, what is critical section? Have you heard about this word critical section? What is it? No. Yeah, correct. Almost correct. But still. Critical section is a code inside which only one thread should be there at any time. Where some critical code is there. Two threads should not be there inside the critical section at a time. Only one thread is allowed inside the critical section, right? The part of the code which should be executed by one thread at a time is called as critical section, right? Now can I say that this method is critical section now? A part of the code which should be executed by only one thread at a time is called as critical section. This method is a critical section. And mutual exclusion says, according to mutual exclusion concept, only one thread should be inside a critical section. Right? And again, in operating system, you might have understood about a term called a semaphore. What is semaphore, if you still remember? A variable on which a lock is taken is called as a semaphore. Here, tell me, what is a semaphore? The object on which you are taking a lock is called a semaphore. Here, which object is semaphore? Bank account object. Lock is taken on what? Bank account object. Here, bank account object is acting like a same operating system process. So I'll just run the program. The output should be same as earlier. Right? Sometimes husband also gets a chance. Sometimes. Okay, fine. Later on. Now I will give an example for you to do. Afterwards, I will continue with the concepts. First, I want you to become confident on these things. Right? Now, what I want you to do is very simple program. In MySys folder, I think you have MySys folder in C drive. Create two text files, a.text, b.text. b.txt. Right? Then I'll just save as in F drive. I'll say a.txt. Inside this, I'll just write some lines. I'll just copy paste some lines. just go to yahoo.com. Now, going back to my wife and husband thread, bank account, synchronization. See here, I just wanted to tell you some more details. Whenever I call start, whenever I create an object of thread, we say that thread is in new state. There are various states for thread. Whenever I create a thread object, we say that it is in new state. It will not immediately run. If I call start, then the thread moves to ready to run state. It will be ready to run. Then thread dispatcher or thread scheduler, which is there, it is the one which will decide which thread to run. There might be 10 threads, 100 threads. Thread dispatcher or thread scheduler will decide which thread to run. And then if thread dispatcher decides that this is the thread to run, then the thread will move to running state. It is running. Every thread will be given some milliseconds of time. It will work, it will run. After the time slot allocated for that thread is over, it will again go back to ready to run state. But when it is running, suppose if this thread has issued an IO command. So let's assume the time slot allocated for the thread is 5 milliseconds. After executing for 1 millisecond, the code inside this thread gave an IO command to a printer, let's say. IO devices are very slow. It will take some time to respond. So whenever this thread gives a request for IO, 4 milliseconds will be wasted, right? So don't want to waste it. What this thread will do is, it will go to blocked state and release the CPU. The other threads will get a chance. Once the IO device is ready, then the thread goes to ready to run. Again, the thread dispatcher will decide which thread to run. If this thread gets a chance, again it will move to running state, execute. So finally it will come to end state. This is the life cycle of a thread or various states of a thread. One more thing I want to tell you here is, here if I make this synchronized block, only one thread can be inside a synchronized method, is it? But what about performance? If I make my method synchronized, will the performance be decreased? Yes, because you see here, my earlier one, this one test, here I am starting 2 threads, but I made each thread to sleep for, see the output is coming at a slow rate, is it? Why? When the thread is sleeping, other thread also cannot enter. Other thread also cannot enter. It is taking lock and sleeping. The other thread also cannot enter. So taking locks on an object makes other threads to wait. Waiting means decrease in performance. So taking lock always is not a good idea. Take lock only when necessary, right? So now the point I want to tell you is, if this method is so big, the locking time also is increased, right? But now I have a scenario where the logic is like this. So there is some code here and there is some code here. I want lock to be taken only for these lines. I don't want lock here and I don't want lock here. I'm not expecting some synchronization issues for this code. I'm not expecting synchronization issues for this code. I'm expecting that there are some synchronization problems in these lines of code, right? If I make the whole method as synchronized, what will happen? Even though your thread is executing these lines or these lines, lock is taken, right? I want to reduce the locking time. So the thing is, it is not a good idea to synchronize the whole method. Only synchronize this part of code, right? synchronized methods. Use synchronized blocks. Synchronized blocks look like this. I'm keeping whatever code requires synchronization here inside synchronized blocks, and I'll say. So now what happens is, if I write like this, when a thread is entering this method, lock is not taken. This code will execute without lock. When a thread enters inside this synchronized block, it will take a lock on its object, and when the controller comes out of this block, it will release the lock. So by using synchronized blocks, I am reducing the locking time and increasing the performance. So 100% don't go for synchronized methods. Use synchronized blocks wherever necessary. Right? Now, once you understand this, I have one more question. Think logically and tell me. Let me see how many logical brains are there. I have a class X. Okay? Just think logically. And I have a method M and another method N. Okay? In this method, I am using synchronized of this and writing some code, and here also inside method N I am writing synchronized block. Right? Now see a scenario. The code inside method M, the code inside method N are totally independent code. Even though method M and method N are executed concurrently, there will be no problems. Right? Right? Even though one thread is executing method M and one thread is executing method N concurrently, there is no issue. There is no problem. This is the code inside method M and method N. Right? Now assume two threads, thread 1, thread 2. Thread 1 is inside the synchronized block, sleeping. Right? Then chance came for thread 2. It wants to enter inside this. Will it be able to enter? Thread 1 is already inside synchronized block and it is sleeping. Thread 2 got a chance to execute this method, synchronized block. Will it be able to enter? No. No, two threads. Thread 1, thread 2. Two different codes. Two different code, not single code, same code. I wrote thread 1 extends thread 2 extends thread, two separate classes. The logic is different. Thread 1 calls M, it is inside here. Thread 2 calls N, it is inside here. Sorry, thread 2 tries to call, enter inside this synchronized method. Before entering inside synchronized method, lock should be taken on this object. But here already, when thread 1 is entering inside the synchronized block, it has taken lock on this object. Right? So when thread 1 is inside the synchronized block, thread 2 cannot enter inside this synchronized block because it also needs a lock on this, the current object, same object. Right? So this is not so good code. So how to avoid such problems is, I will tell you a scenario. Synchronized block requires one object, right? In this case I pass this. Instead of that I will say a dummy object O is equals to new object O1 O2. Okay, then here I will say synchronized of O1, here I will say synchronized of, right? Is it okay now? Is the problem solved? See, synchronized block some object reference on which you take a lock on. Whenever a thread is entering inside this one, it will take a lock on O1. Let's say it is still sleeping. Thread 2 tries to enter inside this synchronous block. It requires lock on O2. This is totally different object. It will take a lock and then go in. Right? So no problem. The idea is don't use synchronize of this. This means same object. Even though there is independent code here and here, when one thread is inside one synchronous block, other thread cannot enter the other one. Right? So whenever you are using synchronized block, let this block take a separate object here and here. The performance will be increased. Any doubts in this theory, let me know. Tell me whether I am doing correctly or not. Instead of making this as instance variables, I will make them as local variables. Now, tell me if I am doing correctly or not. Any problem with this code? No problem? Sure? Yes. Let's assume that thread 1, a scenario where two threads T1, T2. Thread 1 enters inside M. There is a local variable. Local variables are stored on thread stack. So for each thread there will be one stack. So for thread 1 there will be one stack, and here this is for thread 1, this is for thread 2. O1 will be created on the stack. It is pointing to some object, right? Thread 1 takes a lock on this object, enters. Again, when thread 1 is still inside the synchronized block, thread 2 tries to enter again M here. What will happen? For thread 2, O1 is local, right? Again, another reference variable O1 is created. It is pointing to new object, because local variables are one per thread. So for second thread also, O1, it will create object 1, a new object on its stack. Both of threads are having their own stacks. Local variables are created on stacks. Then it will take a lock on this object, and that will also enter. So both the threads are entering synchronized block, which is not correct. So don't make local variables when you are giving this object for lock. Make this as instance variable. Local variables are one copy per thread. Right? Any other doubts? So that's about synchronization. Any doubts? Let me know.